All right, folks. I've had a bunch of people ask me about inserts, how I make them, how I print them. So this is going to be a little mini tutorial on how I model an insert out, um, and how I set up my slicing for printing. Now I use resin printers and Soraya Tech True Blue version 2 clear resin, um, and it works great for me. So yeah, there's that. But anyways, this is how I model it out. Um, so let's create a new part. And generally speaking, you can make any shape insert you want. You really don't want lots of in cuts on inserts because then you're going to have weakness in wood. So we're going to mainly keep with like shapes and whatnot. So let's go top. Um, and for this insert, how about we make it kind of, I don't know, a hexagon with like a pole on it, almost like a stop sign, I guess. So like this, um, and then the radius of this can be 3, 1.5 inches maybe, and then um, yeah. So we'll take this. I'll extrude this. Here's extrude to half inch. I'm sorry, quarter inch, because play inserts, when I make my inserts, they go halfway into the playfield. Um, I think that's standard too. So now let's add some other weird shape. I don't know. How about just like a bulbous thing on the top and bottom? So sketch. We'll do a slot from here to here. Out the corners. So I mean, it's not really anything fancy. It's just something as an example. And then extrude up to surface here, the bottom surface. So that gives us this shape. Now, when installed, this actually could be kind of neat as like a when installed horizontally like this as a sign type of thing. So that's actually kind of neat. I like that. I might save this insert, but it's just easy to model it this way because of how I oriented things. But I actually could go into here because I didn't exactly orient this precisely, so I can rotate that one, make it vertical. And then that'll set that. Okay, so now this is more of the signish type shape, right? Then all these corners here, all these sharp corners or inner corners, I always make those a quarter of an inch, or I'm sorry, an eighth of an inch fillet. So every one of these things becomes an eighth of an inch, and we'll lose a little bit of the point, but that's okay. Technically, these top and bottom points can probably go down to like 3/32 or maybe 1/16, but it's best to keep it all the same. I use 2 millimeter end mills when I trim, so this works really well with those when I need to cut the shapes out in the playfield. Okay, so now we have that basic shape. Next, I go to the bottom, I click shell. I shell it with 1/16 inch. And that just hollows it out about, there-ish. Now, one thing I could potentially do, which, I can show this example, depending on what your shape is and how weird it is. And this one, it might make sense to do this because of the odd shape of it. Um, this top section, which is currently, if you look at it, this is 1/16 inch from the top to the first like open section. That's not very thick, and for small round things or square things or tiny inserts, it's fine. But for something this size, I might want it extended a little bit more. So what I can do is I can select that thing. I can create an extrusion based off of this contour. And I can pull it down maybe another 16th. So it gets about an eighth of an inch thickness, and maybe a 16th is too much. Maybe a 32nd of it is fine. Yeah, so that just adds that extra little bit of thickness there. That, again, for larger inserts, you're going to want a little bit more body on that. For smaller inserts, it's not as big of a deal. Okay, next step, the infamous triangles. So if you noticed, the center point of this is the center point of this sketch. So all of my basic planes originate from the center of this object. And I did that on purpose. So now if I take the front plane and I do a sketch on the front plane, this sketch, I can say make a little triangle-y type shape, and then I need to align it so it's good. So the center point of the triangle needs to be the center point there. The center point of the triangle needs to be in the center point of the sketch. So this needs to be vertical. So in a shape this size, I'm probably going to do 0.15 width, and then a length of, a length of 1/8 might be fine. How about 3/16? Yeah, 3/16 wide and 1/8 deep. Now notice I'm not pulling this all the way down, so it's uh, coincident with this. I'm having it pulled in a little bit. I mean, model it however you want. This guarantees like all the edges and corners are in the solid itself, and there's no weird formations when I start pattern or making a circular pattern of this thing. Okay, so now this is the triangle, and this can be adjusted also once we see what the pattern is. Let's go to the side view, or I'm sorry, let's go to the top view, and we want to features extrude this, but this extrusion needs to come as far out as this edge. So we're gonna bind that, we'll say like 2 inches for funsies, because I don't exactly know how long that edge is, and 2 inches should make it to the end. All right, so now if we go back to a 3D solid view, we have at the bottom here, we have one of our little prism pieces. And what we can do is, again, going back to the line view, we can take this extrusion and I can circular pattern it. Actually, I can't do that yet. I'm sorry. I need to first create another sketch on the front that just has like a vertical line going up, because that's going to be our axes of rotation. So now I can highlight these two things, look at the top, and say features circular pattern, and boom, it's like spinning all over the place quite a bit. Now I've made inserts like this previously, which is why this is almost correct. If you look on the left, I'm doing a full 360-degree spin. The the axes, which it didn't even select my axis. Come on, select it. Yeah, it's, you don't always need it, but it's good to have the center of axis sometimes. So the axis is the center point that is spinning around 360 degrees 32 times, and obviously the 2-inch extrusion that I have is plenty far enough to go to the edge of this piece. And it's also set to equal spacing on this on the left here. What you'll notice though is this section here doesn't fully cover the prism, so we have gaps still here, 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 and here because of the length of this. So to fix that, let's bump it to 34. There's still a gap. Let's try 36. And there's a tiny gap. Let's make it 37. And that more or less covers the gaps. So 38 just for posterity. Yeah, that fully covers the gaps. So now any where'd my mouse go? So any of these gaps originate outside of the intersection of this. So let's say okay. Now if we look at um 3D view, now obviously this looks weird, but if we go to the bottom, yeah, are you why are you being weird? That's not what it's supposed. What happened there? Oh, oh, because I'm patterned. I accidentally clicked the hexagon to pattern also because you can pattern multiple objects. Hang on. Let's go to this shape. Get rid of that shape. Now let's look at the bottom. Yeah, there we go. Um, Now, interestingly enough, there's still gaps there, probably because that hexagon was mucking with things. So let's go to 40. Okay, now I think many of those gaps are mostly gone. There's a little bit left. Okay, at 42, it's all gone. So now it's just the prism shape coming in. And as you saw, it was a little bit of trial and error. And now this has that nice little starburst bottom pattern. And this insert's perfect. There's nothing wrong with it at all. I say in jest. So, okay, next step. We need to get rid of all this crap. Easy to do. Click the top of the insert. Click sketch. Make a new sketch with that. Convert the shape of that insert so that because that's the shape that we want, and then make a gigantic circle that covers everything else, and extrude cut all the way through the entire through all through the whole thing, and then boom, that removes all that extra crap. So now we just have our starburst on the bottom. The final piece that you really kind of need to do with your basic insert. Now, obviously, you don't need the starburst, but the starburst actually also does add rigidity to the thing if you 3D print it or model it. Um, well, there's a couple more things I guess you could do. So, in a case like this, what I would probably do, come on, go to the bottom. Actually, yeah, go to the bottom. I would start a sketch here, and I would make a series of circles. Let's let's not be dumb about it though. So a circle there, circle, circle. Really? Circle there. Probably a circle there, circle there. Now, traditionally, these I think would be like injection mold sections, but inserts tend to have them in various spots. So let's just do a bunch of those. We'll make all these equal to I don't know an eighth maybe. We'll see what it looks like. We'll and is no 0.1. We'll make them 0.1 inches. And then of course we should make them not all over the place. So let's put a square alignment here or a rectangle alignment that's just for construction. That way I can guarantee all these points are what are you attached to? Oh, don't do that. And then this rectangle should be centered on the center point. So this center point should be in the um center point should be the midpoint of this. Now I can kind of shrink this a little bit just so those dots are kind of like right on the cornerish type of things. There. Yeah, sure. Um, pull this down a little bit more. Yes, I'm being particular about. Pull this down to here. My nose is really itching because of allergies. I'm sorry, folks. I want that to stay 0.7, and I want to stretch this out. So it's more in the corners of these things. And then likewise, these things here, top to bottom. Why do you think you're fixed some you're not? Stop thinking you're fixed some. Okay. And then this point is also center line to this, or midpoint to that. And these come and kiss the top like that also. Okay. Let's extrude this up to the surface. There. Hide this sketch. We don't sketch anymore. So that adds those little, those little dots that you see on inserts and things all over the place. Again, it just adds a little bit more authenticity. How about we make this dot a little higher? 0.725. Yeah, that looks a little bit better. Right, so that looks pretty neat, right? Okay, next is the draft. So inserts do need to have a little bit of a draft along the edge, so you can push them into the wood and let it pinch into the wood. It took me a while to learn it, so thank you, Lonnie, for beating that over my head. So the way I make my draft is I choose a chamfer. I pick the lower edge for the edge for the chamfer. And why do you not want to show me chamfer? Because it's and right, because 0.02 and 83 degrees is usually what I do. So you can see right along the edge that adds just a little bit of an in cut, so it can press into the wood and kind of pinch, but it doesn't go so far. If I go to stop spinning around, but it doesn't go so far that you look at the bottom. It only kind of comes in maybe a 32nd of an inch around the perimeter, less than that. Maybe 128th or 328ths of an inch or something like that is probably more like it. Something. Anyways, it's not that much, but it's just enough to help that pinch. And let's say okay. So now we have a little bit of a draft all around the insert. You can push it in. The insert has enough body that it's not going to malform or twist. It has these little dots because why not? So that is my basic insert. So I'm going to save this because I like this shape. And this is going to what should I call this? Diamond 9 1.5 inch door. Now, the one other thing I do on my inserts when I print, because I find it incredibly easy to help align things and get things perfectly flat, is I add a hat. So if I go and I create a sketch on the top, offset the entities by 1/16 of an inch, and then extrude by 1/16 of an inch. Now, when I print this, I'll have this extra little flange on the top. And when I push this into the playfield and hammer it down, it'll be like perfectly flush with the top of the playfield. Or, I mean, the main part of the insert will be like perfectly flush with the top of the playfield. Then when I run it through my sander, it'll be like crisp, like beautifully crisp, and I won't lose like I won't lose too much material. A lot of people like to leave the insert raised up a little proud just so they can sand it flush. But in doing that, you lose a little bit of that 1/4 inch insert at the same time, which also means you lose some body and you lose some rigidity. 3D printing isn't as great as injection molding, so I don't want to lose it as much as possible. So adding this little hat gives me that flange that allows me to line things up to the top perfectly every time, and also gives me that extra little bit that I can sand off without compromising the integrity of the insert itself. But anyways, so this is how I would print the insert. So let's save this again. And this is going to go into my uh, print ready thing. This right. Finally, file export or save as. I need to save this as an STL. This is gonna go, STL diamond insert. Wait a minute. When I with SolidWorks, when I export STL, I need to make sure nothing's clicked over here. Otherwise, it'll try to export just that feature, which is really, really annoying. But it is what it is. So save as STL. Yeah. Okay, there we go. All right. Now, I use Chi2 box when making the inserts. This is Chi2 box 2.1 because newer features lock basic things behind paywalls, and fuck that. So get 2.1 or earlier. I think 1.9 is what a lot of people use. Look it up. You can find it on the interwebs and what version you should use. So this is set up for my machine, my DK2. Let's drag this on there. Let's rotate along the x-axis so it's flat. Cool. And then 1, 2, 3, 4, 5. So I can get 6 of these on here comfortably. I might, if I rotate it, I might be able to get more than 6 if I Mickey Mouse around, but I'm not going to screw around with that. These inserts are actually quite large, larger than I expected. Um, so that's what the print is. If I go to slice, here's my slice settings. Again, I use resin, so this is how things work. Typically takes about an hour an hour and 15, an hour and 20 minutes to do inserts. It used to take closer to an hour, but since I added that little flange hat on the top, it adds an extra 5-10 minutes typically. And I'll export this out, save it, and print it, and then in about, I want to say, an hour and 40 minutes, because I need to do cleaning and curing and everything. In about an hour and 40 minutes, I'll have 6 custom made inserts ready to go pop into the playfield. Now, the benefit of doing modeling this way, obviously, is um, if I let's get rid of this flange for a second because I saved things in the wrong spot. So let's save as WL. All right, so let's say, for instance, you want to make a playfield, new part, and top, and let's no sketch the top, please. Yep. Actually, I need an assembly for this. Screw that. Let's just play around, just for funsies for a second. Let's go to a starter playfield and assembly. All right, well, here's a starter assembly playfield thing that I just have that I can drop in. So now let's say, for instance, I want to add that insert in there. Well, I can grab the insert, drag it in. I can mate it the top of the playfield. Wrong way. Let's throw it in the middle right here because it's a nice gigantic thing. And in my playfield, I can go to insert shapes. I can then grab this thing, maybe. How about I click convert entities, and I want the, oh, I'm sorry, convert and offset entities. I grab the perimeter of this thing. Just take a second. And we're going to reverse that, and I'm going to make it 1/32 in cut 3/64 in cut 3/4. This shouldn't be okay. Yeah. 36. Really? Much. Ooh. All right, yeah, 1/32 then. Yeah, okay. So what 1/32 will do, if you look in here, this is where the end of the flange is. So this will allow the flange. No, I'm sorry. This is I'm thinking inversed. Um, not that, because that's gonna be too small for the flange divided by 2. So 1/64. Yeah, 1/64. So that means the flange will be able to fit in to this at the bottom section, but then it'll pinch as it goes around. 64th still seems like a bit. 5, 1. Hang on. 1/4, 1/28. That's not enough. Okay, 0.01. 0.01 inches, I guess, seems to be pretty good. That's like right in the middle there. So you'll get a little bit of a pinch, but you'll have a little bit of a flange slack when putting that in. So there's the shape and then the holes. Let's hide this insert for a second. Then the hole. Edit my holes. Offset and entities. This. Oh, not convert. Sorry. Offset entity. Verse 1/16 inch for the wood cut. Okay. So there's the insert hole using just, shapes from the insert that we just designed. And of course, here is here is the insert itself, place, fitting right snug in that hole. Okay. So that's how I make inserts, print inserts, and get them installed on here. I hope that was informative. I guess this was half-hour video, so cool. See y'all.